and Professor Kanayalal Pandey and yourself, friends, to made me to make this presentation. Today I am going to discuss about the basics of overview of auto leveling. Then I will give a demo on the virtual lab for auto level. Okay, this is the second time I am interacting with you people, students. Means good afternoon, everybody. I think you will have a takeaway today for the virtual lab. Okay, I don't means I think you don't have means this practical facilities. You will be means learning a little bit about how to explore the virtual lab today. First half an hour to 40 minutes, I am going to deliver on a theoretical aspects of leveling. Okay, then I'm going to give a demo on the virtual lab. That is around 11 exercises are there in the surveying lab. Out of 11, I am able to means download only 2 practicals from the IIT Roorkee website. That is on GPS as well as auto leveling, fly leveling. So others I could not download actually. In the meanwhile, after finishing of this session, I will try my level best. If you have any queries, you can ask me afterwards once I explore. Okay, because I am not able to download all other practicals. Continuously, there is a problem in downloading. Okay, then I'm going to stop my video. I'm going to share the content right now. Okay, yeah. Yeah, slides are visible.
Yes, ma'am.
Yes, no? Yeah. Let me know my voice is audible or not. Okay. Yeah, now the session is on surveying virtual lab. In this one, I am going to take yeah. So for better connectivity, please try to follow the instructions. Mute your microphones as well as video for better connectivity. This instruction is for students. And if the session in between something happens, please wait for a while due to technical glitches. And please do not indulge in any other activities during the session because you are not able to understand students because, okay. Please try to concentrate on the classes. We are not able to monitor you people as in a normal classes. So try to concentrate on the class. So this is what you are going to learn in today's session. You will be taught basics of leveling and demonstration of auto level using the virtual lab developed by the IIT Roorkee faculty. Then the course objectives means you are going to operate the auto level virtually to measure the relative elevation between 2 points and to analyze and interpret the measurements. You are going to measure the elevation, relative elevation of different points, and you are going to determine the RLs of given points. These are the course objectives you are going to learn. And these are the list of practicals are given in the IIT Roorkee website. The study of various parts of auto level and to carry out the fly leveling using auto level. The second one we are going to I am going to dig on virtual lab, fly leveling using auto level, second one. Then profile leveling using auto leveling. These things I will explain what is fly level, what is profile leveling, all these things I will explain you. Then observations of vertical and horizontal angles using total station. Total station I will not able to download this practical. Okay, then same thing with plane table also. You have a plane table experiments on plane table survey also, intersection, resection, radiation methods. These are the plane table surveying. Then carry out contouring in the field. Contouring means again it is a leveling only. The 9th experiment is contouring in the field. The study of the global positioning system and its accessories. Out of these practicals, the 10th one, GPS is very simple. You yourself can explore this practical. Okay, if time permits, I will explain you GPS also. Then observations using GPS. Okay, these are the now. What is leveling means introduction to leveling. It is an operation in surveying. It is the most important operation in the surveying to determine the relative positions of points on the Earth surface, especially Z dimension. Okay, we are interested in measuring the Z dimension, the third dimension, not in XY. We are going to establish the relative elevation, that height point, the height of the various points we are going to determine by using a leveling instrument. By this operation, the height of a point from the datum known as elevation is determined. Okay. Now we have here two terms are there. One is elevation, the other one is altitude. So the difference between elevation and altitude is elevation means whatever point on the Earth surface from the mean sea level on the Earth surface. If I am measuring any point elevation means a height of the point on the surface with reference to the mean sea level, then it is called a elevation. Okay. Then altitude means if I am measuring above the Earth surface from the mean sea level, then it is called a altitude. Like a flight aircraft is flying, the altitude of the flight aeroplane we say, not elevation of the aeroplane, because it is flying above the surface of the Earth. That is the difference between altitude and elevation. So with reference to some fixed datum, if you are measuring the objects on the Earth surface, that is called a elevation. If you are measuring above the Earth surface, that is called a altitude. Altitude of the orbiting satellites, like this. Altitude of the aircraft, flying aircraft. Okay, these are the things. That is the difference between elevation and altitude. Okay, why leveling is important in a civil engineering aspect means without leveling we cannot perform a single task in a civil engineering application, construction, whether it is a construction, railways, roadways, or a water supply network, sewer networks, anything. Without leveling, you cannot perform a single task in the civil engineering applications. So leveling is much more important, and it is plays a vital role in civil engineering applications like a design of highways, railways, canals, sewers, then water supply systems and construction projects. Layout means setting out of the works. Once you prepare a plan, we are going to set out in the field now. We are going to set out the work in the field. Work in the field means like a column, central and diagrams, beams, etc., footings, everything we are going to construct on the field. To construct, we are going to set out those works as per the plan given by the architect. So those setting out of construction works we are going to do, and volume of the earthwork. While alignment of your proposing a new alignments for roadways or railways, we will be fixing the route alignment. While route alignment, whether how much is under filling, under means excavation, cut and fill analysis we are going to do, and drainage characteristics of a catchment area. Okay, the rainfall runoff characteristics, rainfall runoff modeling we are going to do by using a basic operation of leveling. Leveling is the basic operation in determining the drainage characteristics of a catchment area also, and topographical map preparation. Okay, the general profile of the ground, that is a topography map. Topography means whatever the natural features like a rivers, streams, forest areas, dense forest, all these things we are going to barren land, bare soil, all these things we are going to map on the topography map sheet, and XY dimensions will be given with a grid, and third dimension Z will be given with the help of a contour map. Contour map will be prepared from the observations what we are going to take from the leveling instrument. And earth subsidence and crustal motion, like tectonic disturbances are there. These things also we are going to determine by using a leveling concept of leveling. Okay, then the basic terms you need to understand in leveling. Leveling means with reference to the horizontal plane, horizontal line of sight, we are going to measure the relative points on the surface of the earth. If you see this figure, this brown color indicating your, see this one, this brown color, this is earth surface, and we have a mean sea level. This one is a mean sea level. This is this dotted line. the curved portion, circular, this one is there. This is a mean sea level, level surface, and this is a level line, mean sea level. Then if I'm keeping a leveling instrument at some point on the earth surface, the line of sight will be horizontal. With reference to horizontal line of sight, we are going to measure the relative elevation of these 2 points. This is red color posts are there. These are the 2 points. In between 2 points, I am going to measure the relative difference in elevation. Okay. So your instrument line of axis, vertical axis will be a plumb line. Plumb line means it is the gravity, through gravity. And reference datum, this is a mean sea level. Okay, this one is a mean sea level. This is a level surface at this point. Level surface means the mean sea level, if you observe the mean sea level, that is the level surface. If I am drawing a line on the level surface by touching each and everywhere, then that is called a level line. The tangential line to the level surface, that is called horizontal plane, level line. On the level line, if you draw a tangent, then it will be a horizontal plane. If you draw a line on the horizontal plane, then it will give you a horizontal line. Now we have 4 terms are there here. The mean sea level, surface of the mean sea level, that is called a level surface. On the level surface, if you are drawing a line, curved line, by touching the level surface, then it is called a level line. If you draw a tangent plane, the plane tangential to the level surface, then it is called a horizontal plane. If you are drawing a line on the horizontal plane, then it is a horizontal line. Okay. Then the vertical line means, vertical line is always with reference to the one horizontal line you are going to measure the vertical angle. Okay. So while measuring a vertical angle, we are going to have a one horizontal line, and the other one will be any line, that is with respect to the elevation of the object. Okay. So vertical line is always normal to your horizontal plane. Okay. Whenever we have a instrumental measurements are there, like optics, the light ray we assume means it is a straight line, but it will not be a straight line due to the atmospheric refraction as well as Earth's curvature. Earth's curvature is a curvilinear nature, and the light ray is going to bend a little bit for a long sides. So the refracted ray will be in a dotted line. This is the dotted line. Okay, this one. But we assume in the optics, the line of sight will be horizontal. So we need to make the necessary corrections while observing these things. Okay. Now, means as compared to, we have Earth surface is a three-dimensional spherical in nature. Yes or not? If you want to model the mathematical, the shape of the Earth, to measure the area, volume, or a distance, we need to fit into a mathematical model. That model is called the approximate shape of the approximate shape of the Earth surface is called a geoid. Okay, this is a geoid. The approximate mathematical model of the Earth surface is called geoid. Okay, from the geoid we have a mean sea level. Mean sea level. Then this is a natural terrain. This green color is indicating a natural, the actual shape of the Earth surface. Okay, at any section. Then this magenta color is indicating your approximate surface, means shape of the Earth surface. And you have a mean sea level. Mean sea level. Then you have a ellipsoid means it is the perfect mathematical shape of the Earth's surface. Okay. Geoid will be having a irregularities will be there. But ellipsoid, you will be having a complete elliptical. The mathematical formula related to ellipse we are going to use, ellipsoid. So here we have a local definitions as well as global definitions for ellipsoid and spheroids. So in leveling, the more important thing over here is what you exactly you are measuring in leveling. Relative elevation we are saying. Yes or not? What happened? Any questions? Anybody can, if a student is asking questions, any host, other host can unmute and tell me about the clarifications.
Ma'am, question will be asked after session.
Hello?
Question will be asked after session.
Last, no? Okay, okay.
Yeah.
Then no need to respond to this chat box, no? Raising
No.
hand, all these things.
No. It will
Okay,
after session.
fine. So what exactly we are measuring, you should know beforehand whether which height I am measuring, from ellipsoidal height to or earth surface I am measuring, or ellipsoid to mean sea level to natural surface of the earth, or GI to this mean sea level. What I am measuring actually, I should know beforehand, because there are many confusions or misconceptions in measuring. Actually, we measure the leveling means we are going to measure from the mean sea level. Okay. Every country for a construction, the civil engineering application part, we are going to measure the relative elevation of the points with reference to mean sea level, or we are going to take any arbitrary meridian. But in GPS, you might be knowing about a GPS a little bit. GPS gives the elevation data with respect to the ellipsoidal height, ellipsoid or a spheroid height. This we won't consider if you become a technocrat after your BTech. So be careful about GPS measurements. You need to convert the GPS heights to the mean sea level. Otherwise, the government organizations, they won't accept your readings, whatever sophisticated instrument you use, but they won't accept your readings, because the GPS will give you the elevation values from the ellipsoidal height, ellipsoid to the natural terrain. This from green line to yellow line, that the GPS will give. But what we need from the mean sea level, the blue line to green line we need. Okay. Or geoid. This is a mathematical representation, approximate mathematical representation geoid. Whether you are going to measure the geoid height or ellipsoidal height or orthometric height. See, in the next slide, you will be knowing this one. See, here, one, there's a geoid, this is a geoid MSL. Okay, mean sea level. This is the ellipsoid. This is the topographical actual surface of the Earth surface. So this small h is the ellipsoidal height, from the ellipsoid to the natural surface of the Earth surface. Okay, then from ellipsoid to your this one, ellipsoid to geoid, that is called your geoid height. Okay, ellipsoid to geoid, that is a geoid height. Then this is the orthometric height. Orthometric height means from geoid shape to natural surface of the earth you are going to measure. Orthometric means the all the projection lines are parallel and normal to the paper plane. Okay, ortho means the scale is uniform in orthometric height. Everywhere your projection plane is normal to the all the projection lines are normal to the paper plane, and all the projection lines are parallel in orthometric height. So generally we measure the geoid MSL, mean sea level. With reference to mean sea level, we are going to measure the RLs of the earth surface in leveling. Okay, means you have to be clear about ellipsoidal heights and MSL heights. GPS will give you the ellipsoidal heights. We are going to measure MSL heights. MSL heights will give you the accurate results in a local area. Ellipsoidal heights at a global means a scale, this will give you accurate results. Okay, this is a model, how you are going to model the same thing I have shown over here. This is ellipsoid, and this is a geoid MSL, this one, and this is a irregular shape of the earth. Okay, this is the basic terms in leveling means already I have explained you what is level surface. Level surface means it is the equipotential surface of the Earth's gravity field, and it is the sea surface is a level surface. Any water body, the surface of the water body is a level surface. If you draw a line on that one, like a coconut, what you say, a leaf, coconut leaf, that stick will be there. Now, if you put on a water surface, then it is going to touch at each and every point. That is called a level line on the level plane. Okay. Then datum means it is a reference surface of a constant potential called a level surface of Earth's gravity field. Datum means we take the mean sea level as a datum for measuring the elevations of the points. One of such of the mean sea level surface and is considered a standard datum. Okay, and this surface may be adapted as a datum also we can adapt. For a local construction surveys, we are going to take a arbitrary datum also. Arbitrary datum means any chimney or a tallest object permanent object, you can fix it as a datum, and you can take as a that elevation is about 100 meters. From that 100 meters, you are going to carry out. I will explain in the meanwhile. Then level line means a line lying on the level surface is a level line. It is the same. So it is a curved line. Already I have shown you in the figure, these figures. Then horizontal line means this horizontal line is a tangential line, which is tangential to the level line on a level plane. Okay, then vertical line means it is the line which is indicated by a plumb at a required station, and it is perpendicular, always perpendicular to the horizontal line. Okay, datum already mean sea level. And mean sea level, how we are going to mean sea level means average tidal height. The height of the tides in a local area we are going to measure. We have like a Bay of Bengal is there, then the Indian Ocean is there. So the hydrographic survey people, the government of India oceanographic studies, they take a average of 19 years for a long periods they are going to consider, and they average these tidal heights to get the mean sea level. The mean sea level or MSL is used, above mean sea level, AMSL, or below mean sea level, like this we are going to use, is used as a datum for important surveys of that zone. And RL means reduced level means once we are referring with reference to mean sea level, then it is called a reduced level. Reduced level means the nothing is absolute no, in the earth surface, everything is relative only. So relative measurement, the height of any point on the earth surface, I am going to refer with reference to the mean sea level or any arbitrary datum or reference datum. That is called reduced level. Reduced level is vertical difference between the level point and the datum mean sea level. You can take datum as a mean sea level or any arbitrary datum also for local surveys. Okay. Again, benchmark is the point laid above or below the datum line with a known elevation mark is considered a check for the other leveling points. At least you have to have a one minimum benchmark to establish your network of the control points for a Z dimension, that leveling. Okay, if you don't have any benchmark established by Survey of India in your area, from other areas for important surveys, we need to transfer that benchmark from the other places, nearby villages or somewhere. Okay, like generally in railway stations, you have benchmarks established. Okay, समुद्र तल से इतना ऊंचा है, वो लिखा रहता है उसमें. Okay, now these benchmarks are of much more important in a leveling. So these benchmarks are developed, means established by then British government in 1800s only, means the Great Trigonometric Survey, we say GTS benchmarks. Okay, the GTS benchmarks we have, then permanent benchmarks, then we have a temporary benchmarks, then arbitrary benchmarks. See here, the GTS benchmarks means they are established by the government agencies only, as well as permanent benchmarks also. These will be established by government agencies. Then Survey of India is going to establish permanent benchmarks. These Great Trigonometric Survey benchmarks established long back. Till now we have preserved those benchmarks. This figure is one of the GTS benchmark established by the British government. See here, if you see the Pune junction, mean sea level 560 meters. This is the elevation RL of this point, railway station. Okay. This will be written over here. Almost all the railway stations you will be having this mean sea level, the RL of this point. Okay. Sorry. Then temporary benchmarks means, like I have told you in the local surveys, we are going to establish a temporary benchmarks like this. Okay, this is the permanent benchmark. This is a GTS benchmark. This is an arbitrary benchmark, or you can say temporary benchmark. Generally, we follow in laboratory experiments, etc. You are going to mark with a pen, and you are going to take that point as a benchmark for your survey. These are the now how the setup of the GTS benchmark is. The GTS benchmarks are not visible to you. It will be underground. Okay, this is not a benchmark actually. Benchmark will be driven inside. It was driven inside. It is a concrete block of 6 feet by 6 feet by 6 feet block is there. Inside that one, this setup, you see this setup. Inside that one, you have a 6 feet by 6 feet by 6 feet concrete block will be there. In that block, you have a this bottle and neck arrangement will be there. Here you have a brass plate will be. This brass plate is indicating your GTS benchmark, RL of that point with reference to the mean sea level. Okay, Great Trigonometric Survey means they have carried out the leveling operations for the entire country by using a theodolite, the optical theodolite. That's why it is a trigonometric surveying. See, this is the benchmark, that point, the pointed like this. See, the point, it is like a wedge shape. The wedge will be like this. It is like a sharp edge will be there. This edge is indicating your benchmark. Okay. So the plumb will be there here. Then it is a bottle arrangement will be there. Here you have a brass plate will be there, thin brass plate with a pointed edge will be there. That is your benchmark. So benchmark will not be, the GTS benchmarks will not be visible to your on the surface. It is driven, it was driven below the ground at a distance of 6 feet below ground level, and 6 feet by 6 feet concrete block will be there. Inside that one it is driven for the security and safety purposes to retain the points for a long periods. So these are the points they have established in entire India to cover in 1800s. They have established from all over the India. This is the triangular irregular network, TIN, triangulation network they have carried out in means from 1800. So it is almost, they took 50 years of time to finish the survey by using a theodolite. Okay, then coming to the experimental part, we have some basic terms. How you are going to take the site from the leveling instrument, whether it is a dumpy level or auto level, whatever it is there. The basic terms you need to understand. I think third semester students are also involved. That's why I'm explaining a little bit. The backside here, the backside means a site taken for a point of known elevation. Don't think that backside means you are taking a backside from the backside of the instrument or something. Already a site taken means you are going to establish the relationship between benchmark and your survey. That's why we are going to take a backside on the benchmark. Benchmark means a point of known elevation. Already आपको पता है उस elevation. अगर उसी पॉइंट का फिर से आप एलिवेशन मेजर कर रहे हो तब उसको बोलते हैं बैक साइड. ओके, साइड टेकन फॉर ए पॉइंट ऑफ known elevation, that is called a back side. Then foresight means or intermediate side, side taken for a point of unknown elevation, and foresight is the last point. Actually means it is the last point in the survey. In between you have a rough terrain is there. Rough terrain means like my terrain will be like this. Okay, I am not able to establish. If I am taking one point over here, the other point over here, I will not be knowing the elevation of these points. Yes or not? So I am going to take in between sites also. I am going to take, if I have established my instrument over here, I am going to take one site over here, the other site here, the other second, like this I am going to establish a intermediate sites also. Now here it is a benchmark for me. This is the benchmark. Okay, this is the benchmark. From here, from benchmark, I am going to establish. Benchmark means already this elevation I know. Let us take 100.0. 100 meters is the elevation of this point. Okay. Same point, wherever I know the elevation, I am going to put my staff on the benchmark. Then that is called a backside. The all other points are foresight are entered there. For this setup, this is the foresight. This is the foresight. All other stations are intermediate sites. So that I am going to have a proper profile of the ground. These are the intermediate sites. Intermediate is a site taken in between your backside and foresight. These are called intermediate sites. Foresight means a site taken for a point of unknown elevation. Even intermediate site also a site taken for a point of unknown elevation only. Whenever you have a topographical difficulty or you have a visibility problems, then we are going to establish a intermediate sites. Okay. Then station means here, see, with reference to other practicals in survey, station means here leveling staff. This is the station where you are going to keep your leveling staff. That is called a staff position is called a station in leveling, not instrument position. This is not the position. This is not instrument station. Station means staff position. This one. These are the stations in leveling. Okay. These are the stations. wherever you are keeping a leveling staff. That is called station in the leveling. Then a station point at which both backside and foresight are taken by turning the staff to relate the elevation values from a new instrument position. That is called a turning point or change point. Means whenever you keep your instrument at one place and you are continuing your leveling, from that instrument position, the other points are not visible. Then what I am going to do, I am going to keep my staff at the same place, previous position, and I am going to shift my instrument. Again, I am going to take the staff reading for the previous position only. That is called a turning point or a change point. Okay. Then, so coming to the types of leveling, you can perform the leveling with reference to the different instruments, like a direct leveling or a spirit leveling, then barometric leveling, then trigonometric leveling. Direct leveling or spirit leveling, this we are going to discuss, and most of the institutes we have direct leveling only right now. Barometric measurement, through gravity measurements, we are going to establish the relative elevation of the points. Gravity measurements we are going to take. Trigonometric leveling means theodolite or a total station we are going to use for a trigonometric leveling. You are going to measure the vertical angles as well as a horizontal angles in trigonometric leveling. The GTS benchmarks have been established by trigonometric leveling, not by direct leveling. But today's class, we are going to discuss the types of leveling in direct leveling or spirit leveling. Means you will be having a telescopic instrument will be there, and you have a horizontal line of sight here. So I am going to take a staff reading at two different positions. If I want to establish a relative elevation between this benchmark and other point, I am going to keep my instrument in between somewhere. Then I am going to take the staff reading on the benchmark and staff reading on the this one. So the relative difference between these two staff readings will give me the relative elevation between these 2 points. If I am referring with reference to the benchmark, then I am going to now see, now the benchmark elevation is 820 meters. Here it is 8.42 feet is the staff reading. Here I have a 1.2 feet. Now what is the RL of the instrument, height of the instrument? 820 plus 8.42. Yes or not? 828.42 meters is this line of sight, relative elevation. From this line of sight, if I subtract 1.2 feet, then I am going to get the elevation of this X, point X, like this. Okay, this is called direct leveling or spirit leveling, or we say for this particular setup, we say differential leveling. Differential leveling means the difference in elevation between 2 points we are going to measure. Barometric means gravity measurements we are going to take, because the Earth's gravity field is going to change from place to place. Based on that one, we are going to measure the RLs of different points. Trigonometric leveling means vertical angles as well as horizontal angles we are going to measure. Now, the methods in direct leveling. Now we are going to discuss about the spirit leveling. Okay. And differential leveling means already I have explained you. Difference means on a continuously sloping grounds like this, continuously sloping grounds, we are going to perform the differential leveling. Here you are going to take only back side and foresight. Generally, we won't consider the intermediate sites in the leveling operation, intermediate sites. Okay. So, and we are going to keep the distance from the instrument station to backside and instrument station to the foresight. We are going to keep a approximately equal, so that even if our line of sight is not proper, means the instrument you didn't set up properly, there will not be any error in the leveling values, the RLs of the points, if you keep your distance between the backside and foresight is same. Means from the instrument station, this is the distance. See, this is the sorry. See, this is the distance from instrument station to backside. Okay. Then distance from here to here. These two we are going to keep equal, almost approximately equal, to minimize the collimation errors. Collimation means line of sight. This line of sight you have to adjust it perfectly horizontal. Even if you won't adjust, then if you are keeping these two distances equal, then there is no error in your measurements. Okay. On continuously sloping grounds, you are going to adopt this differential leveling. Then reciprocal leveling means whenever you are observing a topographical features like a rivers, streams, etc., or a main canals, etc., means main canals, you will be having the width of the river will be very large. Okay. So because of the means the long sides, the atmospheric refraction may come into picture and Earth's curvature also. Okay. Up to after one means almost 100 meters or 120 meters, the curvature effect is going to affect your readings. So that's why we are going to take the measurements from the both the banks. From A, I am going to observe B. From B, I am going to observe A, so that the both the readings observations will be averaged to get the relative difference elevation between two banks of the river. Okay. For long sides, measurements are taken from the both sides to avoid curvature and refraction errors to determine the relative elevation between 2 points. We are going to observe from the both the banks. From A, I am going to measure B, relative elevation of B. From B, I am going to measure relative elevation of A. Okay, this is called reciprocal leveling. Then coming to profile leveling, it is performed in generally in engineering works. Whenever we are proposing a new railway lines or a roadway lines or a water supply network, a canals, etc., we are going to study the profile of the earth surface. Okay, to fix the route of the particular facility, whatever facility we are going to provide. So it is performed in the engineering work to draw the cross section, longitudinal sections along the route. Along the route means what I am going to do. See, this is my sorry. See, along this profile, I am going to take from the zero chainage to some 9 kilometers something we have. In between, what I am going to take, I am going to take this is the route. Perpendicular to this one, I am going to take the cross sections also at different chainages like a 0, 3, 5, 7. Like this, I am going to take a cross sections with longitudinal as well as a laterally also you are going to take the RLs of the different points. Okay. Okay, to draw this cross sections as well as longitudinal, number of intermediate points sites are taken for complete and accurate profile. Means if your profile is irregular, then we need to take a number of intermediate sites in between your back side and foresight for the accurate profile. This is your profile leveling. Profile leveling means with reference to see, if you see this figure, these are the stations. Station means staff portion, wherever you have found out the elevation. And these are the elevation values. If you draw the profile of the longitudinal profile, this is same thing with reference to datum. With reference to some datum you are going to take. With reference to datum, what is the profile of your ground, that you will be knowing. These are the values from the different chainages, from benchmark, from like whatever the kilometer stones will be there, 0 meter chainage, 30 meters, 60 meters, like this we are going to extend our survey. This is the site and the height of the instrument, the intermediate sites. These are the elevation points you are going to get. Okay. Then fly leveling means whenever I have told you in the beginning, if you don't have a benchmark in your local area, so I need to transfer the benchmark from nearby areas. So that's why I'm going to conduct a very rapid survey, very quick survey to transfer the benchmark from the place where it is to the project area. That is called fly leveling. Otherwise, already one team has finished the survey work. If I want to check that survey whether they have done properly or not, then also we are going to do a fly leveling to check the accuracy of the work done by previous team. See here in this figure, this is my project area. ABCD is my project area, but I don't have a benchmark in this area. The benchmark is somewhere here. So I wanted to connect my survey area, whatever project site is there, I am going to connect with this benchmark. To connect this benchmark, I am going to start the survey from here. So this part I am going to do with a rough method, less precise methods and less accuracy I am going to use, so that I will finish fast. Once the benchmark comes over here, means if I know the elevation of this point, then I am going to take accurate values from here to here. That is called fly leveling. Okay. Then whatever the instruments you are going to use means you are going to use the instruments auto level, dumpy level, and then the accessories. This is the main instrument you are going to use: tripod, leveling staff, all these things, measuring tape. Okay. Then the parts of the auto level means you have a box container will be there. Then you have a focusing this telescopic. This is the object frame. This is the eyepiece. On the other side you have a the focusing screw will be there, and a slow motion tangential screw will be there. Means you are going to turn your telescope in a horizontal motion. Okay. This is the auto level. See here, this is given in your virtual labs. Okay. Even you fixed your instrument a little bit of tilting, the line of sight will be horizontal in auto level, but not in dumpy level. Dumpy level, old instruments for leveling, those create a problem in the line of, if your line of sight is not horizontal, it will give you erroneous results, but not in the case of auto level. If you see this figure, GIF file, even your the telescope is a little bit of tilt is there, still you are going to get a horizontal line of sight only. Okay. Then this is the benchmark, how to transfer the benchmark. And the leveling staff. Leveling staff means, see, you have a the graduated lines will be there here. So here you have 1 meter, then 110 centimeters, 1.1 meter, 1.2 meters, like this. Here, if you observe this one, on top of the black line, it is 1 point, means not 5. Each is 10 centimeters. 1 point, this one, 1 point, this is 1.1, means it is 100 centimeters. This is 110 centimeters. Okay, 100, 101, 102. On top of the black line, it is 101, 100.05. On bottom of the top line or top of the white band is 100.05, 100.1, 100.15, 100.2. Top of the black line is 1 centimeter. Okay, 1 meter means 100 centimeters. This is 110 centimeters. This is 120 centimeters, 130 centimeters. Like this, you will be having a 3 meter staff and 5 meter staffs will be there. Okay. And the instrument telescopic side, you will be having a line of sight. The line of sight you are going to get on the object frame. Once you magnify the focusing screw, you will be visualizing the crosshairs from the instrument, from the leveling instrument, telescopic instrument on the staff like this. So now here the reading is 1.05. Okay, means 100.5 centimeters. This is 100.1, 100.15, 100.2, like this. The picture given here is 100.05, means 1.05 or 100.5 centimeters crosshairs. Now, the basic adjustments in leveling means the setting up, you are going to fix the tripod and a leveling instrument properly without having any tilt. You have to take care of the instrument means very cautiously, because these are very costly as well as delicate also. So setting up but leveling are simultaneous procedures. You are going to means fix these legs. These legs are movable with reference to the person's height. Okay, how tall you are based on. Then focusing. Focusing means you are going to fix the focusing of the object frame so that you can see the earth surface features. Whatever staff you are going to observe, the staff will be clearly visible to you within the crosshairs. Crosshairs should be visible properly. That is called, for leveling, you will be having a spirit level like this. The spirit level has to come in the center. So for leveling, you have a 3 foot screws will be there. For a tripod, these 3 foot screws will be attached to, means you are going to operate these foot screws in 2 different directions. First, you need to fix the telescope parallel to any of the 2 foot screws, whether these 2 foot screws or these 2 or these 2. Then you are going to rotate these 2 foot screws clockwise or anti-clockwise, means inward direction or outward direction. Both the foot screws you need to adjust inward or outward. Once the spirit level comes into the center, then you are going to rotate your telescope in a other direction. Means normal to the perpendicular to the 2 foot screws what you have adjusted. First telescope position is this line, this one. Okay, the second one is this one. Now I am going to operate the third foot screw. Then the completely see, if you operate on 2 foot screws parallel to the 2 foot screws, the bubble will be like this. Okay. If you operate the second operation, if you do, almost it will come to the center once you rotate this one. Whether again you are going to operate this one inward or outward. Okay. These are the leveling operation, how to do the leveling. Then you are going to focus the telescope. This focusing screw, this is the, see, this is the focusing screw you have. This is the focusing screw. This focusing screw you have to move a little bit. Then initially you won't be, the crosshairs will not be visible. Once you adjust this focusing screw, means you have to fix a one white paper, or you have to direct your telescope to the sky. Okay, if a clear sky is there, you are going to focus your instrument to the open sky, or you are going to put a white paper on this one. Then you adjust this screw. Then the crosshairs will be visible clearly. Now your instrument is ready after removal of parallax error. Parallax means the shift of the object from the object frame. Okay, apparent shift of the object from its frame, object frame. That is called a parallax. The parallax error you are going to remove from the telescopic measurements. Okay, now once I explain this one, we go for a demo, quick demo. Okay, now see, this is a leveling. If you observe, this is a benchmark. From here, I have to continue my survey up to here. Okay, this is a TBM, temporary benchmark. Here you have a two benchmarks. This is a just example problem I have given. Now I have to find out the elevation of this A, B, C, D, E, and this temporary benchmark. This is a check for my survey. Okay. At this points, if I want to do, what I am do means first I have to fix my leveling stuff on the benchmark. Okay. Because I'm going to relate my all my elevation values with reference to this benchmark. So somewhere I kept my instrument, first instrument position is over here. This is the first position. Okay. From this position, I have observed this benchmark. The staff reading is 2.191. Okay, then a little bit of topographical difference is there. So I have taken one intermediate site also in between this one also. Then I have rotated my telescope to in this direction. Okay, then I am going to shift my staff position up to here. Okay, then I am going to take the again level 2 point. This is 2.325. Then how much means sight I can see with the same instrument position. Again, I have taken one more. After this one, I am not able to visualize anything, or I am not able to focus my crosshairs on the staff. Then what I am going to do, this instrument position I am going to shift. But the thing is here, I am going to keep my staff over here only. I have taken a foresight over here, this one. After shifting the instrument, the first reading will be backside always, because already I know this elevation. I know this elevation. See, if you observe this one, 49.873 is my benchmark. From here, I have observed the backside. It is 2.191. 2.191 means from here to here, it is 2.191 meters. Then the line of sight, what is the line of sight? RL of the line of sight, 49.873 plus 2.191 meters. Yes or not? That is the RL of the instrument axis, height of the instrument. From the height of the instrument, if you deduct this 2.505, then you get RL of this point you get. Then height of the instrument minus RL of this point, you get RL of this point you get. But here, once I shift this one, again I have to take a backside, because I cannot connect with this one, with this values, with the previous leveling readings, without taking the backside. So backside is much more most important step. After you shift the instrument, first you have to take the same staff position, previous staff position, by turning the staff into this direction. This is the backside. Then again you are going to take an intermediate site or a foresight. It is based on the requirement. It is based on the profile. Okay, this one. So the readings are tabulated over here. This is a station, benchmark A, B, C, D, E. Station means staff portion. Instrument portion we never note down. Instrument, nothing to do with the instrument portion. Station, then chainage, then backside. Backside means the point of known elevation. A site taken for a point of known elevation. Already I know this point elevation. Already I know this point elevation from the previous reading, 50.566. I know already from the previous reading. Then intermediate side, then fourth side. Then these are the calculations. Calculations I will explain you after giving a demo. Then you have two methods over here. One is a height of the instrument method. The other one is a raise and fall method. This height of the instrument I have given RL of the benchmark plus backside, the height of the instrument. See here, if I want to calculate the height of the instrument over here, what I have to do, RL of the benchmark already it is given to you, 49.873 plus backside, 2.191. Then you get the RL of the height of the instrument axis, 52.064. 52.064 minus 2.505. You get 49.559. This is the RL. 52.064 minus next side, your whatever site is there, 2.325. Then you get the RL of this point over here. This is the height of the instrument method. Raise and fall method means whether the relative elevation is falling or raising with reference to different point. Like a benchmark is there, this backside and this intermediate side. See 2.191. This is 2.505. Yes or not? 2.505 means the point is at a lower elevation. So 2.191 minus 2.505. So it is a negative value. So it is a falling gradient. So I am going to note down in a fall. Then next one, next shaft portion is 2.325. 2.505, 2.325. 2.50, this is a raising. 2.5 minus 3 means your ground level is raising. Okay, if you observe the figure, see 2.505 at a lower elevation, this one. Here it is a higher elevation. So 2.50 minus 2.325, this is a raise. Like this, you are going to calculate all the values. Now see, from here to here again, the next shaft portion is 1.496, four side. See the figure also simultaneously, then you will be observing. This is intermediate side minus four side. Yes or not? Then it is a raise only. Once you finish this one, what I had did, the instrument I have shifted. So first side is back side. Yes or not? This is a back side. Then after back side, what I have taken, intermediate side, 2.513. Then again I have to deduct from here, 3.019 minus 2.513. Then you get a raise. Like this you are going to. Now the RL of the station you are going to get RL of the benchmark plus or minus rise or fall. Plus sign you use for rise, minus sign for fall. So 52, this is the benchmark RL of the station, 49.873 minus 0.314. Then you get RL of the station. Okay, this RL 49.559 plus 0.18. Then you get this value, 49.739 plus 0.829. You get like this. Whatever method you adopt, it should be, the elevation should be same, whether it's the height of the instrument or a rise and fall method. I have given two methods in the same slide. Okay, next, I am going to give a demo for auto level by using fly leveling. Okay, these are the the precautions written over there, do's and don'ts. First, whenever you lift the instrument, you have to transfer the instrument with the casing. You cannot take the instrument naked. Okay, so always you put in a container, then you take the instrument. Okay, then once you fix the tripod, then only you have to fix the leveling instrument. Whenever you are transferring the instrument, you have to remove from the tripod, then carefully keep in a box, then you have to fix it again in the other position. Now I will tell you, but because all these operations are not available in the animation software, whatever they have given, the basic operations are there. Putting in the case, the container, it is not possible with this one. Okay, I am going to share the other this one demo. Okay, these are the values for the demo video. Okay, 1 minute, let me check. I'm going to share the content again. Yeah. Yeah. Are you able to see the screen? Students? Prince?
Yes, ma'am.
Yes, ma'am, but
Yeah.
only lining are shown.
What?
Lining is showing.
Only lines are coming.
Lines are coming. Now?
Only lines.
I don't know. One minute. One minute. I'm going to share right now. Is it visible?
Yes, ma'am. Now it is visible.
Yeah. See, 1 minute. 1 minute. See, the objective of the experiment is written over here. Yeah, see. This is to start the experiment. See, you have to read the whatever the quick instruction guides are given over here. These are the ASWD for walk around and Q and Z for up and down. But the terrain is given animated over here, and left control, right control, shift, etc. These buttons are given. Okay, here now see, we are going to walk around first to know the area. Okay, see here they have given some geotech department, civil department, then roads, then one car is parked over here. Okay, see, you just observe, and here some points are given. See, we need to determine the relative elevation of these points A, B, C, D, A, B, C, D, then E, then F is there somewhere. Okay, these are the points we need to determine the relative elevation of the points, whatever they have given over here. Okay, now see this ASWD for walk around and Q and Z. See, Q and Z means see, you are going to lower down your animated video or upward direction. Okay, based on the requirement, you are going to move, and left control and these arrows. Okay, arrow keys, you are going to move the instrument. Okay, this one. See the telescope. Telescope will be moving with reference to the left control and arrow keys. See, it is moving. Then right control and arrow keys, auto level rotation means we have to clamp on the tripod. Now you cannot just fix the instrument like that. You have to clamp so that it won't fall. So for clamping, right control and arrow keys you have to use. Then the instrument will be fixed on the tripod properly. See, the instrument is fixed over here. Okay. Now they have given the points. Benchmark, I have told you now, the benchmark we need to take the first side. Always the first side in the leveling is back side. The back side we need to take on the benchmark. Generally means with the first side taken on the leveling is called as a back side, and we are going to take it on a benchmark only. Okay. Then we need to move the staff also. Staff is kept somewhere else. I will show the staff position. See, this is the staff. This staff portion I have to keep on the benchmark. First, I need to find out where is the benchmark in the site. Okay. See. See, the instrument is given at a benchmark. Okay, the instrument position over here, it is given as a benchmark. I am going to zoom that benchmark. See, you can observe the benchmark, it is written. I am going to magnify this one. See, this is written over here, benchmark. See, benchmark 250 meters, it is written. Okay. See, if you observe this one, See that benchmark, if you are able to see benchmark 250 meters, it is written. Now I have to shift my staff over here. Okay, understood. So for that one, I need to shift my telescope and tripod to somewhere else. The telescope position and staff, you can fix it approximately in a with reference to the previous next reading. You have to adjust your instrument in a probable location. Okay. Now I am going to shift my tripod as well as the telescope to different place so that I can keep the staff on the benchmark. This is the benchmark, this white circle. Okay, now I am going to shift by using the left control and arrow keys, I am going to move my telescope. Okay. Now I'm going to clamp this one. Okay, this somewhere we have removed the instrument. Okay, now see, it is clamped. It is rotating on a this vertical plane around the horizontal plane. Okay, now we are going to move the staff to the benchmark. See, this staff I am going to move it to benchmark. See, students, I have taken the help from my son. He is a 7th standard student. So if he is operating, because I never played a video games, I don't know these operations. I have learned for 3 days this animation with the help of my son. So you can do in a better manner actually as compared to the faculty. You will be good in animation because you people are millennial students. See. See. Now what we are taking, you just students note down, you prepare one table, station, one column station, then back side, then intermediate side, then foreside, then height of the instrument, then RL. Prepare a tabular form so that you will be knowing the calculations. I am writing. Now observe the reading on the staff. What is the reading? First column is station. Second column is your back side. Third column is intermediate side. Fourth column is foreside. Then you are going to follow any method, height of the instrument or a raise and fall method. Then RL of the benchmark, then remarks. This is the level book we say. First column is station, second column is back side, third column is intermediate side, fourth column foreside, fifth column is height of the instrument, sixth column is RL of the points, seventh column is remarks. Okay. Now see what you are going to just note down the reading. It is reading is 0.95. Yes or not? 0.95. How we have done this one? First, you have to keep approximately staff you are going to keep. Then staff you are going to rotate with reference to the telescope position by using the left click mouse. The click means the middle button, you can rotate the staff towards the telescope. To move the staff, you have to use the left shift. The left click of the mouse button. You have to have a mouse with your laptop. Without mouse, you cannot operate. See, with the left mouse button, you can shift the staff to different position. With the middle button, you can rotate the staff. Okay. You can rotate. Now see the staff reading, it is 0.95 or 95 centimeters. This is kept at a benchmark. So it is a back side. The station is benchmark. Yes or not? Station, in the remarks, you write benchmark and you note down this reading as a 0.95 meters or 95 centimeters. Whatever you want to write, 95 centimeters. And RL of the benchmark is given as 250 meters. Now, what I have to do? Now I am going to take a several points are given, the A, B, C, D, E. Several points are given. So I am going to take an intermediate side or a foreside based on the visibility from my instrument position. Now I am going to keep my staff, move the staff to the position B. B position. See, B position by using a left click, you are going to move the staff, leveling staff. By using a middle button of the mouse, you are going to rotate the staff with reference to the telescope direction. See, on the center point you have to keep. Okay. Yeah. Now see. Now see. You need to move the telescope by using a right control and arrow keys. Whenever you fix your staff, don't use the left control and arrow keys. If you are moving a left control and arrow keys, the telescope is going to move from its position. You are going to clamp and rotate. Means it is going to move in a one particular horizontal plane only. Okay. It has to move in a horizontal plane while taking the reading. While taking a C, here it is the right control and arrow keys for auto level rotation to clamp. In a clamped position, it is going to rotate about its horizontal plane. Okay, horizontal axis is going to move. Okay, be careful while doing these operations. Now you see the value is about 0.96. Okay, 0.96. This is the intermediate side, or it is a 4 side. This is station B. Station B. Station B reading is this much. Next. Now we are going to check whether from my instrument position, the C point is visible or not. That you have to check beforehand. Actually, in the actual site conditions, we will be approximately knowing whether it will be visible or not. Manually, you can observe. But here it is animation software. I have to move the staff to C position. Then only I will be knowing. Okay, and with practice also you will be knowing. See, now I am going to keep my the staff position and a C position. Whether it is visible or not, just you right control and arrow keys. Okay, and 0. And one more important operation is to shift between, toggle between your telescope and crosshairs. Okay, crosshairs you have to means press 0. Press 0 to see the telescope, or you want to see the crosshairs. So obviously I have to see the crosshairs only. See, now it is now see, I made a mistake. The telescope has rotated a little bit. Now I have to fix the telescope properly. See the fix. First I am going to fix the, by chance I pressed on the telescope button. See, telescope has moved. Yes or not? So these are the mistakes you may commit in the initially. But now I have to bring back. Never means press other buttons. You have to use the control, right control and arrow keys. Okay. Now it is moving in a, now right control and arrow keys, it is going to move in a horizontal plane. Horizontal plane. Okay. Now the reading I am not able to see properly. I am going to zoom this one a little bit. Okay. Yeah. See, it is about 0.24 meters. We are going to move a little bit the telescope in a horizontal plane only. We are going to move. Okay, just you move in a horizontal plane, nothing will happen. Our RL is same, because I am now, see, actually I have to shift this operation is not possible while you are conducting a field, but here in the animation you can shift your telescope a little bit in the same plane. That is the option you have in a virtual mode. See, now it is visible. See, it is about 1 means it is a 0.95 meters. Again, it is a 0.95 meters. Yes or not? 0.95 or 0.97 meters. 0.9, yeah, 0.97 meters. This is a intermediate side to you. C also it is a intermediate side, 0.97. Okay. See, next. Actually, see, you cannot move the telescope like that. For a time being, I am explaining like this. Okay, you have to move the telescope as well as tripod along. But means in an animation, we have opportunity to move in a same the vertical plane. Okay, same horizontal plane I am moving. So nothing will happen. Now this reading, the third D point may not be visible. So you need to shift the instrument. For shifting instrument, again, I have to keep my staff at a position C only to take the back side. First, you check whether it is visible or not. This is not visible. See, the staff, it is at a higher level. So what I have to do now, I am going to keep my staff in the same position, previous position C. I am going to shift my staff to C position. Now I am going to move my instrument and tripod to a convenient position so that I can see D and E. C, D and E. So second position I am going to shift. Now I have kept them the same position to take the back side. Now I am going to shift my telescope as well as tripod. Actually in animation, if you observe, we don't require a tripod actually in animation. But in reality, you have to have a tripod and the legs, so 3 legs you need to means adjust to see the horizontal line of sight. First, I have moved my telescope. Telescope also you cannot move like this. You have to keep in the box and you need to move in actual this one. I am going to move my this one also. The tripod also. Tripod I am moving right now. The staff I am going to move. Staff at C position. Tripod I am going to move. I am going to bring the tripod over here. Actually, in this animation software, no role for tripod. So you cannot move the legs individually here. They didn't give you options for to move the tripod legs individually. And the plumb bob is also given, if you observe, the plumb bob is also given to measure the distance from the center of the instrument to the staff position while doing a differential leveling. Okay. Means to calculate the gradient, we need the distance also. Distance also we are going to measure actually in the actual site. So those operations are not given over here. It is only to take the staff readings and you are going to move the instrument, whatever operations you do for focusing, etc. Okay. So you need to keep the instrument in such a manner you can see C as well as D. C and D should be visible from the instrument position. So you need to move the instrument to a convenient position. Left control and arrow keys to move the telescope and right control and arrow keys to fix the instrument on the tripod. Okay, now you see the value is 93, 91, 92, 93.5 centimeters. Yes or not? 0.935. The backside is backside to the previous position C. Now you have to write the previous reading 0.95, backside you got 0.96, you got intermediate side, and 0.97 foresight. Now on the foresight only in the same line you have to note this reading. This reading 0.97, I think so. No, 91. It is 91, 92, 93.5. So 93.5 is the backside reading, which is we have taken already. We know the elevation of that point. Okay, this is the elevation. Now I am going to observe the D. I am going to move my staff to position D. Position D, I think so. I don't think so. It is visible from here. So I have to take again. No, it's not visible. So again, I have to take the back side. Okay. No, it's not visible. It's not visible. So I need to take the back side again to the C by shifting the instrument a little bit again. Instrument I have to shift. Instrument I need to shift in between C and D. In between C and D, we need to move the instrument. Tripod also we need to move. Now for the time being, I am not moving the tripod. Okay, I am moving only the telescope to a convenient position between C and D, so that I can see. But tripod height, in actual site, the tripod will be having a fixed height. You cannot move like that actually in the actual field. But here we have an opportunity to move in a different manner. Okay, because we are moving in a horizontal plane only. I'm going to bring the tripod also. So it will take a little bit time to habituate to the animation. So you need to find the C position also. C and D should be visible from the instrument position. Yeah. Where is the location? Now you check the location. See, by pressing the 0, you will be going to see tripod is somewhere else. Yeah. Now see, it is not visible. So you need to keep in a different position. This is a see. By pressing 0, you will be knowing I am going to move this instrument again to a different location. First, I have to roam around a little bit. See the C position as well as D position I have to see properly. Then only C. This is the C position. This is the D position. Yes or not? So for C and D, otherwise I need to take the intermediate points in between C and D also. Tripod also I have to move. C. I am going to move the staff to C position right now. Leveling staff to C position. Oh, yeah. So before operating these things, you should know the concept of taking the measurements. Why you are taking a backside, why you are taking an intermediate side, and foresight. You should know the basic difference between backside, intermediate side, and foresight. The backside means you are going to connect your survey data with reference to the previous leveling values. Okay, that is the yeah. Yeah, see, now the staff, now I am going to rotate my staff by using a middle button of the mouse. Staff and telescope also. Telescope I am going to keep on the tripod. Yeah. Now rotate the staff. Staff is, we need to rotate the staff by using a middle button of the mouse. So now it is 0.81. Okay. 0.81. Yeah, it is 0.81 meters. This is the back side at C. Means by turning the staff, we have taken the back side. Now I have to see the D point. Now we are going to move the staff position to D to take the foresight or a means intermediate side based on the D point I have to move. This is the procedure to do the virtual lab on survey, but all the operations are not available, but you know how to take the level staff readings. Okay, see, like this. Now see, it is not visible. This position I did wrong actually. So I am going to stop over here. I think you might have understood a little bit about the animation. See, now this from the instrument position, I am not able to locate the D point from the C, but I have to keep in between C and D only because the points are given till E. Yesterday I have tried, I got. Today somehow I am missing the position. Okay, have you understood? Shall I stop over here? So means they didn't give the position to where to keep the instrument. Generally, the instrument position is not that much important, but means it is the visibility for the back side as well as intermediate side only. Nothing to do with the instrument position, but based on the topography, we need to adjust the instrument properly so that you can see the back side as well as intermediate side. Okay, this is the way you are going to do back side and intermediate side, foresight, then back side, intermediate side, and foresight based on the requirement you are going to take, and you are going to note down the values values in the level book, that the entry of the leveling values, the back side, intermediate side, foresight values in a that book is called level book, we say. The first column is station, back side, intermediate side, and then foresight, then the height of the instrument, then the RL of the points, relative elevation, then remarks you are going to write. Now I will explain the tabular form over there. Okay. Yeah. 1 minute. I'm going to stop sharing of this one. Yeah. Yeah. See, for those, whatever the positions they have given, see, are you able to see the screen,
Yes, ma'am.
students?
Yes, ma'am. Visible.
Yeah. See, if you take means these values will not be same for the when you conduct a practical, you won't get the same values because they didn't give the where to keep the instrument position. Instrument position we need to fix based on our convenience. So the values may change a little bit. Okay. Not little bit, based on the where you are keeping the instrument, the values will change, but the difference between A and F will be same. It should not change whatever values you get, but the final result will be it should be same between point A and point F. The difference in elevation should be same. That is the check we are going to do. See, once you enter these values, the station A, B, C, D, E, F. See, at station A, they have taken a backside over here. At station B, we have taken a foresight. Okay. Foresight they have taken because they kept instrument at somewhere else, 2.105. Then from there, the C point is not visible. That's why they have taken a shifted the instrument in between the B and C. Then they have taken a backside, this backside. Then they have observed the C. This is intermediate side. Then from position, from the same second position, they have observed foresight also, 1.865. From 1.865, from that particular instrument position, E is not visible. Okay, that's why they have taken they have moved the instrument. Again, they have taken a backside over here. Then backside, then you have taken a foresight. Again, the staff is not visible from the position. Then again, we have shifted the instrument. So how many times we have shifted the instrument? It is first position, then second, third, fourth times they have shifted the instrument. So it is a backside. Whenever you are means if elevation is known, that site is backside. Okay. For every foresight, we know the elevation from the calculations. See, these are the sigma of the backside and sigma of the foresight. So you are going to get the difference. You are going to get the between A and F. That is the difference in elevation. The calculations are, see, the backside, intermediate side, foresight, and height of the instrument. In the figure, if you observe that figure, line of sight means height of the line of sight of the instrument axis. Okay, instrument axis. The RL of the benchmark will be given to you. RL of the benchmark, it is 250 meters actually, but the calculations they have shown 560.5 meters RL. But it is 250 meters. You can take anything. RL 100 meters also you can take. It won't change. Okay. So 560.5 it is written. 560.5 plus backside. 561.365 you got. 561.365 minus 2.105. Okay, then you get this RL. This RL plus backside. Then you get a new height of the instrument because we have shifted the instrument in between B. So again, you got the new height of the instrument. New height of the instrument minus of your, again, your this site, 1.580. Then you get the next new point RL you get. Okay, 560 point this one minus 1.865 because the instrument is same up to here. then you get 550.420. Here again, we have shifted the instrument. So I have to add this RL 558.420 plus 2.230. Then again, I get the new height of the instrument here. Again, from the new height of the instrument minus your foresight, then I am going to get this new RL. RL means relative elevation of the new points you are going. Like this, you are going to continue your survey. The check for survey is sigma backside minus sigma foresight equal to last RL minus first RL in height of the instrument method. Okay. Whenever you are adopting a height of the instrument method, there is no check for the intermediate sides. That's why we need to avoid, if you are using the height of the instrument, you are going to take only backside and foresight. We should not take any intermediate side because there is no check for the intermediate side in height of the instrument method. But in rise and fall method, if you see the rise and fall method in the below table here, the rise and fall method, you have a check for intermediate site also, because the rise or fall, it is related to the two consecutive readings. Okay, staff readings from first reading to next staff reading, whether the ground profile is rising or falling. So the intermediate site also I am taking a intermediate site also I am going to take into consideration. See, 0.865 minus 2.105. It is a raise 1.240. Yes or not? Then again from the foresight, again I have shifted my instrument. So backside, this one. See, from here to here. Again I have shifted my instrument. That's why I have taken a backside. This backside 1.025. 1.025 minus 1.58. Okay. This is fall. Fall means the ground is below the previous level. So it is a fall 1.555. This one. Okay, then 1.58 minus 1.865. Again, it is a fall. Okay, then again I have shifted my instrument. I have to go to backside. Backside minus again this 2.2835. Again, it is a fall. Okay. Then again I am going to go for a backside here. Again, we have shifted the instrument 4 times. Then again 2.355 minus 1.76. It is a raise. This is the only one value we have a raise over here. The raise and fall. Now to calculate the RL of the next point, what you are going to take 560.5. This is the RL of the benchmark. RL of the benchmark minus fall. If it is a fall, you are going to take minus. If it is a rise, you are going to take a positive value from the next value, 560.5 minus 1.24. So you are going to get 559.260. 559.260 minus 0.555. What is the new RL you are going to get? From new RL, you are going to subtract 0.555 like this. 558.705 like this. 558.285. You get this one. 558.42 minus 0.605. You get the next elevation. 557.815 plus 0.595. You get the. So the check over here is sigma backside minus sigma foresight equal to sigma raise minus sigma fall equal to last RL minus first RL. See, the check is same. Backside minus foresight equal to sigma of backside, summation of backside, summation of foresight, summation of the raise, summation of the fall. Sigma raise minus sigma fall. That should be equal to last RL minus first RL. Okay. These are the means the values over here. Okay. Now, these are the references what I have followed to prepare this lecture. And thank you, all of you. And let me know any questions or clarifications. I hope you understood.
Anybody wants to ask any question?
Let me know, have you understood the lab or not, virtual lab? Because the concepts your teacher is going to deliver you, respective faculty members. Now, if you try, you can do the practical on the virtual lab.
Here is some question on the text box, message box, ma'am, from a student.
Chat box.
Yes, ma'am.
Chat box, so they didn't ask any questions so far. Have they
How,
asked?
how to set total station at B station? We didn't know about MSM over there. In
Prince, your voice is not 1 minute. Let me check which student has given.
Ma'am, Abhishek Priyadarshi.
Abhishek, what he has given?
He has given how to set total station at B station. We don't know about MSL over there in
No.
reciprocal
No
leveling.
need of MSL. See, MSL we are going to have at one position only, benchmark. That benchmark is given at A. Yes or not? The benchmark is written over here. It is a 250.0 meters. Yes or not? So I'm going to fix it a convenient position, the instrument, to take the backside first. Okay. Then I am going to fix my line of sight. Then what I am going to do, I should not shift the instrument to B. I have to shift my staff to B. Next reading. Understood? I am going to keep my instrument at the same place, telescope at the same place. Backside as well as intermediate side or backside and foresight I have to take from the same position. Then only I am going to establish the relative elevation. Staff I need to shift it to B position. But whatever the position I have considered to fix the table, means the telescope, that should be in a convenient position so that I can see the benchmark as well as the next point. That is the criteria. Understood, Abhishek? You can unmute and otherwise you can ask me. So you need to shift the instrument to a convenient position so that your means a previous side as well as a forward side is visible from the same position. If the next point is not visible, there is no problem. But from the one position you have to see in the last C and D. I faced the problem in setting. The same problem you are going to face if you are not fixing the instrument at a convenient location so that you can see the back side as well as a intermediate side or a foresight. At least two sides you have to take, one back side and one intermediate side or foresight. You can see any number of intermediate sides and foresight from one position if topography permits you. If topography is not permitting, then we have to shift the instrument or we have to move the instrument to a convenient position so that you can take the minimum of 2 staff readings, one on back side, the other one on intermediate side. Is it okay, ma'am?
Yes, ma'am. Ma'am, there is one more question from Shreyas Saxena. He is asking, how do we change the ellipsoidal height to MSL height?
Yeah, ellipsoidal height to MSL height means it is a transformation techniques. Okay, the ellipsoid means ellipsoid is a global datum. Okay, MSL is a local datum. So we have a 7-parameter model we are going to perform that is comes under physical geodesy. The x-axis translation, x-axis rotation, y-axis translation, y-axis rotation, then z-axis rotation, z-axis translation, and one scale change. Okay, this is not an easy task to perform like that. If you have a GIS softwares or a photogrammetric softwares, you can convert those ellipsoidal heights to these MSL heights easily. But manually, it is a difficult task to convert the values from ellipsoidal heights to geoid MSL heights. Okay, the transformation technique you have to perform to convert the readings from ellipsoidal heights to ellipsoidal heights to geoid height. It is difficult, but MSL heights to geoid height you can convert because it is a scale change. Means we are going to work at a local scale for MSL heights. And if you are taking ellipsoidal height, we are working at a global scale. From global scale to, means from small scale to large scale map, you cannot prepare. Yes or not? From large scale to small scale, you can prepare. So converting ellipsoidal heights to MSL heights is a waste of time because the accuracy is going to diminish. If I am converting the MSL heights to ellipsoidal heights, it is okay. The reverse may not happen. So while taking readings only, we have to fix the GPS to the MSL heights, or you have to use a transformation technique.
Okay, ma'am.
Is it fine?
Okay,
Yeah,
ma'am.
it is like a large scale to small
But
scale.
ma'am, he's again asking, why was the MSL in one of the slide curvy rather than straight?
MSL will not be straight. Means level is a curved nature, curved line only. The water surface, any water surface, if you are observing a water in a pond or a sea or a river, the water surface is not a level surface. It is a curved shape. That is the level surface.
Okay. Is it okay,
Which slide?
Shreyas?
Which slide? Always the level surface, the mean sea level is always a curvilinear in nature. Okay.
Okay.
If I am drawing a plane on the level surface, then the level plane will be tangential to the level surface. Okay. On the
Okay.
level plane, I am going to draw a horizontal line. That is called horizontal plane. So leveling means we are going to take the readings from the horizontal plane. We have to ensure the telescope will be at a having a horizontal line of sight.
Okay.
Okay.
Okay, ma'am. There is one more question from Shivani Pandey. She
Yeah.
is asking, ma'am, which type of bottle is used in the concept of benchmark and how it works? What is the role of bottle in the benchmark concept?
Which this benchmark, GTS benchmarks.
Yeah.
GTS, that is a bottle and neck arrangement to fix that brass plate. It is a pointed brass plate will be there. Okay. To means a plumb line we have to maintain. Na? For plumb line, we have the bottle and neck arrangement. Plumb bob will be there. The plumb bob will be inserted over there to see the particular level.
Okay, ma'am.
That is the
There is
arrangement within the, because I also didn't see the GTS benchmark inside. Okay, because it is a outside view only everywhere. In Bangalore also I have observed in a Survey of India campus, it is a GTS benchmark is written over there, but it will be below that one. But the arrangement is like that, so that it won't means go in deep, or so wherever we have fixed at a 6 feet level, that should be at a 6 feet level only for a several number of years, hundreds of years. That is the concept behind fixing the GTS benchmarks at a 6 feet below the ground level, so that nobody can tamper those benchmarks. But most of we have lost so many benchmarks over a year.
okay, ma'am. There is one more question from Manish Dev. He is asking, in flying leveling, we check accuracy, but if there is error in transfer of benchmark, then how we check accuracy?
Transfer of benchmarks means, see, at a local level, local scale, the means the it won't differ much. It won't affect much. The benchmark means quick leveling we are going to do with a less precise methods means, whatever methods they have adopted to fix that benchmark, we won't adopt same methods because it is very costly to establish the primary control points. So what we are working at a third order control points. If you have a triangular irregular network, we have a first order triangulation point, second order, third order. So if I am working at a site level, my level of accuracy can be at a third order level, not at a primary level. So that much accuracy is enough for my project, construction project. If I am establishing a geotic control points, then I have to transfer. It's not a transferring of benchmark. We are going to establish a new benchmark for a primary or a secondary triangulation network. The Z dimension leveling points, these means vertical control points, I am going to establish a new points if I am dealing with a first order or a second order. If I am at a third order, even I am using a less precise methods, nothing will happen to your transferring of benchmark. Means the third year students can understand what I am saying. The third sem students may not understand because we are working at a local level from the third order level. So we are using a benchmark from the second order or a first order triangulation. So it won't affect the quality. Is it okay, ma'am?
Yeah, yes, ma'am. It is okay.
Yeah.
Next question is, ma'am, how to convert orthometric height to ellipsoidal height?
Orthometric height. See, ellipsoidal height means we are going to deal with a latitude and longitude. Yes or not? Ellipse means the ellipsoid means geotic means the latitude and longitude, and height we are going to, datum height we are going to take. Orthometric height means we need to project. Projection means we have to project the ellipsoidal surface to planar surfaces like a UTM projection, universal transverse Mercator projection, or a polyconic projection we need to use to convert the ellipsoidal heights to orthometric height, because the projection lines are means parallel as well as normal to the paper plane. These means modifications you cannot do manually. One or two values you can do, but all the values in the image means in the area you cannot do manually. These conversions, because these conversions are at a global scale or a local scale, regional scale. Regional scales for India are like this. Okay, you have formulas are also there. If you open any physical geometry textbooks, you will be knowing the, if you see the orthometric height, that small h equal to capital H plus n, plus or minus n, the orthometric height, and ellipsoid height, geoid height, you have a relationship. If you observe the figures, what I have given, you can establish the relationship between orthometric height, ellipsoid height, and a the geoid height. Okay.
Okay, ma'am. There is one more question. Arbitrary benchmark and temporary benchmark both are used for same purpose of having difference in work.
Which one? Temporary benchmark and
And arbitrary benchmark.
both are same. Arbitrary benchmark, see, temporary benchmark or arbitrary benchmark, if I have any tallest tower or a chimney or some permanent building is there, so I'm going to use that surface as a temporary benchmark or a arbitrary benchmark for a local survey. If I am constructing my home, I won't transfer the benchmark from other place. I don't require actually the permanent benchmark. Yes or not? So I'm going to take the road level or any other neighboring house. I'm going to consider as a benchmark to fix my columns or a beams or a footings like this. So that I am going to use as a construction surveys. If it is very important survey, then like a railway bridges, you have so much impact of a vehicle load, etc. So there we need to consider the relative elevation. It is going to affect the structure, loading, etc. There we are going to consider proper values. For a local surveys at a individual level, no need to consider these permanent benchmarks.
Okay.
The leveling values won't change, na relative elevation. Relative elevation won't change unless until your project area covers more than 100 kilometers or something. Then I have to consider the permanent benchmarks, because it is based on the project area, how much area you are considering. Okay.
One more question. What is the chainage? This term is used for road survey, and how and where it is taken while doing the leveling survey.
Chainage.
Chainage, yes.
Chainage means, oh, sorry, I forgot actually put it. The chainage means from the one staff portion to the other staff portion, station points between station. Station means in leveling, the staff location is called station. So between two stations, that is a chainage. Back side to the intermediate side, or a foreside, that is the chainage. Or intermediate side to next intermediate side, that is a chainage. So 0 meters means you are going to have at a benchmark, that is a 0 meters chainage. And you are going to take an intermediate side, that is like a 20 meters. At a 20-meter distance, you have kept a staff, that is a 20 meters chainage. Then next intermediate side is 30 meters. From one staff portion to the other staff portion, the horizontal distance measured is called a chainage. The chainage generally we get from the DC's office. District commissioner will be there now. There in the towns or cities, the 0 kilometer stone starts. That is a kilometer stone. Chainage comes from the kilometer stones. You observe in the generally the national highways, etc. 0 kilometers, 20 kilometer stone, 32 milestone. Milestones will be there now. That is the chainage.
Okay.
And clarified or not, any further doubt is there. Chainage means the distance between the one staff portion to the other staff portion is called chainage. Not from the instrument portion. Okay, not from the telescope portion. It is between two staff stations. Chainage means.
Okay.
First staff station you can take as a 0 chainage. Second staff means like a 20 meters or a 30 meters chain you are using, or a tape. 0, 20, 40, 60 like this. We are going to append at every 20 meters. If it is a plain area, there is no problem for the visibility. You can have a same equal length. 0, 20, 40, 60, 80, up to the telescope capability you can take. If it is a rough terrain like our animation, the IIT Roorkee's animation, so you need to shift the instrument time to time based on the terrain conditions. So whatever it is there, the in between two staff stations, that is called the horizontal distance is called chainage. The first point is zero chainage. Second point is whatever distance you are measuring. That is the chainage. Okay.
Okay, ma'am. There is one more question. In geodetic survey, we take Earth curvature is taken into
Yeah.
consideration. It
Yeah.
is 250 square kilometer or 195 square kilometer.
It is written in a different textbooks. In BC Punmiya, it is written 250 square kilometers. In other textbooks, it is 185 square kilometers. Okay, maybe miles are typographical mistakes. Generally, we consider 250 square kilometers is if it is exceeding the survey area is exceeding 250 square kilometers, then the curvature effect is going to affect your survey data. So that's why we are going to consider the curvature of the earth is also into consideration. The survey area is more than, you can do a simple calculation also. You take the 6370 approximately radius of the earth. Okay. The arc length is 250 kilometers. Then you calculate how much difference it is coming. D square upon R we do na, the curvature calculations. The d square upon L equal to d square upon L equal to R theta. L equal to R theta if you put, if you take consider a chord length, if you consider as an arc length, so how much difference it is coming, you can calculate easily. Okay, see, if I share the screen, I can tell you. The radius of that is 6370 kilometers, na? 60 above mean sea level. How much distance you are taking the measurements from the mean sea level? Yes or not? At a 250 meters above mean sea level or 800 meters above mean sea level. So you are going to, if you are considering the curvature of the earth, then you are going to consider the arc length. Yes or not? If you are ignoring the curvature of the earth, you are going to take a chord length. The difference between chord and arc gives you the deviation from your RLs. Understood? Hmm?
Yes, okay, ma'am.
Otherwise, I am going to share the screen. I will draw the figure. If
That is okay, ma'am. They have written it is okay. They have
student
understood.
requires. Okay. The difference means the differential elevation between the chord length and arc length. Okay. That is the
Okay, ma'am.
difference you are going to get. You can easily calculate for 185 square kilometers or 250 square kilometers also.
Okay. There is one more question. What do the terms telescope normal and telescope inverted mean?
Yeah, telescope normal means the regular position, line of sight will be horizontal. Inverted means you are going to, the bubble will be up in the inverted portion. Telescope inverted means you are going to have a vertical line of sight. Whenever your benchmark is somewhere else, benchmark is not on the ground, it is on the top of the building or something. So how can you observe that benchmark? Benchmark sometimes we take on the top of the building or a beam or any other artificial man-made features. Then you have to take that on the telescope inverted or a normal. Okay.
Okay,
Normal
ma'am.
portion, the line of sight will be horizontal. But if I am considering a telescope, means actually these, the telescope, it is applicable for theodolite actually. And leveling generally we have a line of sight will be horizontal only. Staff inverted we say, not telescope. Okay. The terminology is sort of means applicable for theodolite surveying. Here we are going to take a staff inverted. Whenever we have a benchmark on the, we are considering a top of the building or something, your leveling instrument is above the your benchmark. Then we are going to take the staff inverted. Okay.
Okay, ma'am.
Staff will be inverted in leveling operations, not telescope.
Okay, okay.
Okay. Yeah.
Okay. Anyone else? Another question?
If you do the animation, na, you will do better than me actually. As a student, so you will be knowing animation tools very well. I will agree because we are in good in the conceptual and we are means good in operating the actual instrument. And this is new for me also, animation. For the last 3-4 days, I have means practiced
But
this.
ma'am, the way you have explained it doesn't seem that it is new to you.
Yeah. Actually, frankly speaking, I have learned from my son.
Okay.
He's 12 years old. He
Okay, okay.
completed. I have explained him concept. I wanted to deliver this lecture because you are playing video games. So you explain me.
That's very nice.
Yeah.
Okay, thank you so much, ma'am, for sparing your valuable time with us and enlightening us with such an interesting and knowledgeable lecture. I am from mechanical background, but still I was able to understand the concept.
Okay.
So that was so effective, and it was really appreciable how you have visualized the whole things. Thank you so much, ma'am.
Thank
It
you
was
for
pleasure hearing you. Thank you.
yeah, I am thankful to your university as well as the civil department and mechanical department also because you are hosting. Okay,
Thank you,
thank you.
ma'am. Thank
Yeah.
you so much, ma'am. Okay, now there is an announcement for participants. Today's session is over. You have to again join it tomorrow at 10:30. Your attendance link is posted in your WhatsApp group. So from there you have to fill it, and it will be only active till 3 p.m. Okay, thank you.
Ma'am, shall I leave then?
Yeah, ma'am. Okay, ma'am. Thank you, ma'am. Thank you
Thank
so
you,
much.
everyone. Yeah, thank you, students. All the best.